Okay, guys, welcome back to the channel. Hope you had a great weekend. Mine was pretty busy. Nightlife as well as day life. Day life entailed many groups this past weekend coming over to demo the Bach and my system. And this video is going to kind of parlay some things, takeaways from that. But the primary purpose is to follow up on a YouTube short that I did last week showing FTC new regulations for wattage specs for amplifiers. And what are the implications of that and changes, but not just go into the basics. I actually have an amplifier manufacturer on this video giving Steve McCormack, one of the most legendary amp designers, as well as preamp designers, universal disc players. He started the whole modding industry with Mod Squad, started the whole vibration control industry with the Tiptoes, and also DSD recordings. Does it all. He's going to give you his perspective as well as a better way than even the FTC's specs for measuring and determining the performance of an amplifier. And I think that's much more of the value here than just learning the FTC changes. How can you interpret these measurements? Which ones are worth a grain of salt, several grains of salt, or a lot of salt, and how to interpret them, or who to ask when you don't know. Getting that right person to connect with and connect the dots for you is really one of the key takeaways of this video. But it also parlays into what I was doing this weekend in demos here. Many people come back here and they listen and they're like, oh my God, how are you able to get this performance? It's better than any of the dealers in town or the shows we go to. How are you able to get that performance? Well, a lot of it obviously is the Bach and the technology I'm using. But on top of that, even one of the person came back here has a Bach. But it has to do with a lot of things we talk about in this video, Steve McCormack and I, about specs in a vacuum or measurements of a piece of equipment in a vacuum are very limited. It's not going to tell you how it's going to sound particularly, and especially some of these stats are meaningless. Some, though, have more value than others. And then how these pieces interact together, which I also touched upon in my preamp and amp synergy. That is actually much more important to, quote, measure or have an understanding of how the measurements will make these things work together. Because some things that look poor will be meaningless to what you hear. Other things that look great will also be meaningless to what you hear. So understanding these measurements, and whether you want to learn on your own, this video will help give you some education there to get that started, and I'll do a lot more in the future. But also, if you just, I don't want to get into all those weeds, I don't want to learn all that stuff, I just want to push play, enjoy my video, totally get that as well. But I'm going to show you people I trust, the leverage, the knowledge I have, the WhatsApp group, where you can leverage other people who actually do understand this stuff. Don't all just talk in audiophile, nebulous jargon and saying this is the best, that's the best. That's a red flag right there. But also on the flip side, strictly ranking things based on measurements in a silo of how they perform in static conditions, that's a minefield as well. So this video is trying to help connect the dots, and one I'm really proud of. It's not going to be for everybody, not for the drive-by audiophiles, but I think for a lot of you guys, you're really going to enjoy this. So sign up, subscribe. I have plenty more coming soon in this same vein, and also a big announcement later this week. So without further ado, maybe we could let Steve get into some of the nuances that he took away from the FTC changes.
The links are going to be good because if anybody who's interested can read this stuff. It's fairly clear. I mean, there's quite a bit of legalese involved because they are trying to come out with some new legal definitions that will be, in some sense, requirements. I'm a little unclear on the exact nature of the force of law, I guess, in this case, we might say, but these things are supposed to go into effect on August 12th, I think it is. So it's the specs all done and you can read the whole thing. But this is an update of something that they started like back in 1974 and then revisited in 2002. And so the whole idea is to clean up their language and set of definitions so that anybody who's manufacturing amplifiers for home use would have a standardized way of measuring power output. I mean, that's what this boils down to, is standards for measuring amplifier power output under certain conditions that are supposed to, in some sense, be closer to replicating home, like real world home conditions. Like for instance, they have to measure an ambient temperature of 77 degrees Fahrenheit. Um, and that's part of the specification. And then they have specs for bandwidth, 20 hertz to 20 kilohertz, and distortion being 1% in this case. And that made me chuckle because when you first told me about this, I think you told me the 1% spec, and I laughed and said, well, okay, that's going to leave out a bunch of, especially tube amplifiers right off the bat. But it turned out that the original proposal for the spec was 0.1%
Right.
version.
That
So
would be.
people jumped on that immediately, and so they've changed it to 1%. Um,
Well,
it's
can I jump in here? I mean, as I'm reading the promulgation on the actual FTC website, I saw that initial 1%, and that was part of the initial discussion. But now the way I think it was finally worded is that it could be more than 1%, but you're going to have to disclose that.
Yes. Yeah, I mean, there has to be a way to do that. And they've put language in this which specifies how, when a manufacturer writes down their specifications, they now have to, use either use these FTC guidelines and say that, tested under FTC protocols, or say that it was not clearly. And they're not allowing you to do an asterisk or a footnote or anything like that. And they were even specifying if you use certain font size to say this, you've got to also add the FTC ruling part of it in the same or a very similar font size. They're trying to stop people from hiding this information or making it difficult for the consumer to see.
Well, I think the wording is actually the FTC specs have to be more conspicuous than any other specs that you.
That is
So
correct.
yeah,
Yeah.
so basically you could show other specs, but it's going to be subject to a smaller font or less conspicuous. At least can't be equal, which is interesting. Sorry for the lighting here. Getting away from the dogs downstairs. Anyway, yeah, so that was very interesting in terms of 1% or whatever the percentage is. I guess the trade-off in the equation here is going to be some amplifiers are going to want to show lower distortion, so they'll lower the power rating because in theory, the power rating will be lower.
That could be true. Yeah.
Or vice versa, they'll want to show more power and they'll just live with the fact that they're showing now specs at 3% to meet the FTC rule. What do you think would be the best trade-off?
They wouldn't be meeting the FTC rule. Then they would have to specify that it was measured, that was not measured according to the FTC guidelines. They have language for that as well, but you got to say one thing or the other. And if you do measure by their guidelines and say so, but then you want to show something else, you've got to say this measurement, was not done according to the FTC guidelines. Now, obviously, there's a lot of amplifiers that can meet these guidelines. I mean, it might change some power spec that somebody's been publishing in the past, and mean that they would have to use different numbers. But there's a lot of amplifiers that can meet this stuff. But when you say 1% total harmonic distortion plus noise from 20 hertz to 20 kilohertz, then there's going to be, some amps, and we're typically talking about tube amplifiers one way or another, that might have trouble meeting those specs. And so those manufacturers apparently, if they go along with this, which has some force of law, I'm a little bit unclear as to, exactly how that would be enforced, but okay. Anyway, they would have to say not, measured according to the FTC guidelines or rules or whatever.
Well, I guess my point is that 20 to 20,000 hertz, they have to measure it, obviously. But then if you have let's say 3% distortion at 100 watts at 8 ohms, you can either say that, or you can say 50 watts with 1%
Right,
distortion.
right.
And both would be compliant. And so the equation that I think manufacturers are going to have to determine is which pick their poison, less wattage and less distortion, or give the bigger wattage but have to show at that 20 to 20,000.
Yeah, okay, because the whole point of this thing is to supposedly reduce confusion and help consumers make an informed choice about the power output of their amplifiers. But if a manufacturer starts saying, 50 watts at 1%, or 100 or 200 at 3%, or whatever, does that help clarify the situation for the consumer? I think a lot of consumers would not really understand what that means, or they go, well, okay, it's 3% instead of 1% for the higher power rating. Is that okay? Is that good or bad? That gets a little bit into this 3D graph thing I was telling you about, which I like as a way to show amplifier power, which is more rigorous than what the FTC is talking about. But I guess the whole idea here is to try to stop some manufacturers from kind of disguising how much power their amps actually put out. I don't think, this doesn't really apply to most of the companies we would ever do business with or be buying from, unless you're buying, cheap amplifiers off of eBay that are, made in Asia, and they're telling you they put out 4,000 watts, or whatever. But those guys are still not going to be complying with the FTC regulations. So I'm not sure how much.
They probably don't care about FTC regulations anyway.
Yeah, we don't care. So, okay, for the people that are going to abide by the guidelines, then hopefully it gives a little bit more uniformity to the specs, and maybe it helps consumers make an informed choice, maybe. But that's the deal. Oh, and by the way, they have that 20 hertz to 20 kilohertz spec. They do have a subsection specifically for self-powered subwoofers. It for those, it limits the frequency response to, I forget what, 150, or there's some upper limit, so they just have to demonstrate their power capabilities within that range. So they're taking into account some of the situations where that 20 to 20K spec would be inappropriate, that sort of thing.
Yeah, and even active speakers, if you have speakers dedicated to certain drivers and frequency ranges, then the specs could be applicable to just that range. So that's important nuance, as more and more speakers are now going active, and several people have satellite subs. So you did bring up your more 3D analysis, because I think that at the end of the day, this is, a positive in some respects. Anything that helps the consumers get a better picture, more standardized measurement. But at the end of the day, these specs still won't tell you how an amplifier sounds and how it's going to perform under even a more varied conditions, other than that 8 ohm for, I guess it's 5 seconds or something, 5 minutes it has to do.
I think it's 5 minutes of preconditioning.
Preconditioning, yeah.
Which is actually a bit less stringent than some of the standards of the past.
Oh, really? Okay.
Yeah. That makes good sense to me. I mean, part of what they're trying to do is have these specs reflect real world conditions, normal home conditions, as opposed to some specialized test environment that's some unusual temperature, or other ways in which it doesn't necessarily relate to home use. But then we get into the question of what those specs actually what they actually mean, how relevant are they really? And as you know, this is kind of a pet peeve of mine over the years. But if it helps the consumers, great. I'll be curious, I guess, to see to what extent we see this show up now in amplifier specs that we'll see that FTC, spec measured according to the FTC regulations, or whatever that wording is. I was telling you about a system that I saw going back certainly over 10 years, maybe longer, that was created by a Swedish company. Hang on just a second. No, company called Audiograph made a piece of test equipment called the Power Cube, and designed specifically for measuring amplifier power under certain dynamic conditions, and I believe it was at up to 1% distortion. Now, hang on just a sec here.
Yeah, you want to share your screen? Because
Yeah,
I found that very fascinating. I had never seen that before.
Okay, have you got me on the screen?
Yeah, I see you. Yeah.
All right, let's start here. So this graphic shows effectively a large cuboid shape. And I hope you can see that we have a voltage on the vertical axis here, and then impedance decreasing as you move forward. So here's 8 ohms, 4 ohms, 2 ohms, 1 ohm. And then across this direction, we've got the phase angle of the reactance of the load. So this is a lot more like a real world speaker. The zero axis, or in other words, coming right down the center here, is resistive. But then you move into inductive phase angles going this way and capacitive phase angles going this way. So what this represents is it's a 3D graphic model of a perfect amplifier. So if you had a literally perfect amplifier and you measured these test conditions, you would get this full cuboid shape. Everything, there's no tilt, it's all flat. These are all completely filled up. Okay, so now you get to real world situations. So here's what they call a good example, a well-designed amplifier. You will find some losses at lower impedances, but those are acceptable. Dynamic headroom is positive for all loads. The cube has a slight V form, but that is quite normal. So what you see is the power falling off as we go from 8 ohms to 1 ohms, because there is no such thing as a perfect amplifier. And so the power supply is doing its best to keep up with the demands of the load, but this is what happens as you reach down to 1 ohm. These are, by the way, these are dynamic measurements. It's not continuous power. So this is more reflective of real world music. This is still much more stringent than actual music, but it's much more representative. And then this particular example maintains its ability to drive these difficult reactive phase angles. Now we come to what they refer to as a poor power supply. All right, so this is another example of an amplifier where the power supply cannot maintain the voltages as we're going down in impedance, although it still does quite a uniform job across the various reactive phase angles. So they say poor power supply. I don't know, that's a kind of a value judgment where maybe the amp was designed deliberately like this. It's a small amp, it's limited, and as long as it does what they want at or near 8 ohms, and then they're cool with that. But by the standards of this test, this represents a power supply that can't keep up with the demands. Okay, then we get into an example that shows bad design of current limiting. So as we get into more difficult territory, especially these reactive phase angles, the amplifier starts actively limiting the current, and the amp can't handle those loads well. And some amplifiers will, the performance is going to suffer badly. So if your loudspeaker is anything other than a pure resistance, which most loudspeakers are not a pure resistance, and it starts getting reactive, then this amplifier, this example, is not going to behave well. And then we get into one that literally goes into oscillation with an inductive load, which, to be fair, is relatively rare these days, but it can happen. And so the point is, this particular example has gotten into trouble with certain kinds of loudspeakers, and it'll just basically shut down at this point. And then here's some more real world examples. So they say it's a well-known Class D brand, home theater amplifier, showing less than sterling performance. And then another Class D well-known brand. This one they actually named, this is a Rotel stereo amp, which shows really very good performance. That's the only brand name I saw referred to in these things. But the point here for me is that this is a way to graph the power behavior of an amplifier into real world loads, much more so than doing static testing with 8 ohm or 4 ohm bench loads. And you can see at a glance, you can look at this and go, okay, I see what's happening. This amplifier is better, at least in this regard, than this one. Now, these things still they don't tell you how an amp is going to sound necessarily, but they do tell you what its power output is going to be as a function of loading. And you can see this at a glance. So this test was used by some magazines initially, maybe in Sweden, but then the Audio Critic picked it up over here. And then I think Stereophile, in my memory, Stereophile used this for a little while. And then it went away in favor of other types of measurements. And I do not know the answer why. I'm curious, and we've spoken about this. So like here is a graph of my DNA 0.5 amplifier. So this is rated 100 watts per channel and 8 ohms. This is the smaller version. I did the DNA one originally, then the 0.5 came out. And this shows very, very good performance. It maintains itself very well and only falls off a little bit into an extremely capacitive load, which typically that's going to be something like an electrostatic, but even those usually they're designed with some mitigation of that capacitance. Anyway, this is very good performance. But I think I'm guessing that what happened is when the magazine started running these graphs, this, in a sense, it makes it too easy to see what's going on. You don't have to dig through charts and numbers and really interpret. You've got a very simple thing that's showing you, bang, here you go. And I have to wonder if this was somehow troublesome for consumers reading these reviews, because what they were faced with is that there is no perfect amplifier. Nothing does this in this test. This would be an outstanding performance for any amplifier, really. And then more typically, you're going to start seeing things like this. And so if you're reading a review and interested in maybe purchasing an amplifier, and you run into something like this at the end under the measurements, I suspect that this may have come across as too negative, and this may have led to complaints by amplifier manufacturers. I don't really know, but I thought this was an extremely useful way to test and a very easy way to see at a glance almost how well an amplifier delivered power into various loads. But we don't see that now and have not for quite some time, which I'm, I am sorry to see it not being used.
Yeah, I mean, I have to echo, and then you even showed me, I don't know if we're going to show the other amps of the day that were measured against your DNA. Their cube was not even near a cube. And I think you're
Yeah.
right that I think that people that are building these mega dollar amps with very fancy heat sinks and all that, when they really would show this kind of graph of what kind of power it can really deliver versus the eye candy test, it would be pretty embarrassing, and especially when you factor in the cost. I mean, I'm using your DNA 0.5s. Now I'm using monoblocks, which are even
You have the DNA 125s.
yeah, 125s. Yeah. So it's even different from that. But yeah, this is something that is peculiar that they did away with this because this would be so much more useful to consumers from a visual understanding perspective. And that's puzzling to me why the magazines wouldn't be doing that if you're a consumer-based magazine and not an industry-based magazine. So I'm glad you pointed that out and showed these kind of specs. Maybe one of these independent reviewers will start picking up this type of measurement.
This does require investing. I don't know what it costs. It's not a huge amount of money, but it's a specialized piece of equipment that produces that graphic output. It's a box that is itself a cube that
Really?
has all of the measurement stuff in it, and you can apparently there's a way to use it kind of on its own, or you can connect it to something like the audio precision test measuring, that the gear, and use that to produce these results. But to me, this is much more meaningful than the typical tests, because it shows the behavior of an amplifier into a reactive load, which is more like a real speaker. Now, when I designed my amplifiers, I was always testing them on the bench with 8 ohm and 4 ohm, and sometimes 2 ohm loads. And so we were looking for RMS power, and when I when I give an amplifier power spec, that was continuous power all day long. And that's fine. I mean, it tells you something about the capabilities and the power supply design and all that kind of stuff. But it's not a real world thing. It has almost nothing to do with music at all. It says, yeah, this is a very robust design with a big power supply. It'll deliver lots of current and it'll just keep on doing it. But again, well, I'm not sorry, I'm not sharing my screen now, but those cube things I was showing you, because they show the reactance behavior, are much more real world, and they're not continuous. That's a dynamics. It's pulsing the power to the amplifier is pulsing into a load, and and then they're looking at this behavior at, I believe, up to 1% distortion, and so what you see is the behavior under dynamic conditions. Again, it's much more like real world, much more like music. I think that's incredibly useful, and that's what I would like to see, but I may be in the minority about that, or
Well, hopefully we can move the needle here because I just did a video about measurements and the fact that, yeah, we can definitely say that certain jargon from certain people with unpolished ears and 100% jargon can be tough to rely upon unless you know that person. But also measurements alone, like we were talking about, depending on what type of measurements, under what conditions, can tell you little or quite a lot about how it's going to perform. And even that bad power supply example that you had, that amp would be perfectly fine with horns, that are
yeah, exactly. I mean, one of the things that's very important to keep in mind is that you might have an amplifier that doesn't look great on this particular type of measurement, and yet it's perfect for you and your system and your listening. And I think that's where any of these measurements get into trouble, is how they're interpreted by the people who are looking at this information. It takes a lot of experience to be able to really look at this stuff and understand how it relates to your particular situation, your taste, your speakers, your room, and what your goals are. And then, of course, we go beyond into other types of measurements, especially around speakers, which may arguably be the least perfect. Any mechanical transducer like that, speakers and phono cartridges, tend to deviate from perfect accuracy by quite a bit. We're at a point in time now where driver technology has improved so much and loudspeaker design has improved to the point where there are loudspeakers that have very low distortion broadband under their normal test conditions, which, they have to test this stuff in some anechoic or near anechoic environment, because you can't take it there is no such thing as a typical room. Now, I realize that there actually is a room defined by one of the testing groups or universities in Canada. So they take equipment in there and say, this is what it tests like in our so-called standard room. But as you know very well, you take a speaker out of an anechoic environment, stick it in a room, and its behavior is going to change dramatically as a function of that room and its location within that room. So there's no way to show a test that that gives the condition or the behavior of that speaker all the time, everywhere. They just do a baseline measurement to say this is what the speaker is capable of, and now you got to try it in your room to see what it actually winds up sounding like. So I started thinking about what measurements would actually be relevant to me. So one of the things that kind of come to mind, and I'll be curious to how you feel about this as well, but I started looking at speakers. I want to know the sensitivity. I want to know the size and weight. And then the nominal, what they say the impedance is, the so-called nominal impedance, but I want to see an impedance plot. So, if there's any seriously reactive peaks and dips, then I can have some idea of what those are. And those will become very important in some situations where the amplifier may have trouble dealing with those impedance, anomalies or issues. And then I'm interested in the polar response. But again, that'll tell you something about how a speaker is going to interact with your room. But if you're in love with open baffle dipoles or planar, magnepans, or planar magnetics and things like that, then you're going to get a dipole, and that's going to interact with your room differently than a direct radiator speaker would. But you're not making your choice. You're not basing that decision on the polar response of the speaker. There's other factors involved. It's, how it sounds to you and your taste. So again, those kind of measurements can just be guidelines, and nothing but getting that speaker in your hands and listening to it is really going to tell you how it behaves for you.
Well, it brings up a good point we talked about in terms of there is a problem with measurements not telling you very much about how it's going to sound, and all the variables you just talked about with speakers are just one. And I'm not trying to discredit those that do measurements because they do serve a purpose in terms of engineering acumen and certain things that you want to maybe just feel comfortable from an internal perspective and engineering acumen standpoint alone. But what I want to do is bridge the gap between these measurements, because some of these videos where it's 100% measurement related, they're spending 30 minutes of time on stuff that's totally inaudible and irrelevant. We talked about signal to noise ratio on a DAC, whether it's 135, 130, 125, all of that is totally irrelevant. So to spend 30 minutes of a video on that spec and even rank things on that spec is, I think, a little misleading, although technically, objectively, it's a valuable metric for people comfort, but it really is not going to tell you how it's going to sound because these are past the audible threshold.
Exactly.
A lot of these 1 foot away measurements, I totally understand how people do. Danny Ritchie's, who builds my speaker, does a good job of modifying speakers based on those 1 foot away measurements. He uses gated measurements, which don't even take, time interface with the room, and only 200 hertz up, which, that's very important. What's under 200 hertz. In fact, I build my whole reputation about getting
Right, but it's very hard to measure.
Yeah, because he knows in a room it'll be totally different.
Right.
But there are now other ways to bridge the gap between those measurements and what value they have is really where I think the industry is kind of doesn't have a bridge the gap of what is this really telling me about how it sounds and how little it really tells me about how it's going to sound. And what I hope to do is show measurements like you're showing with amplifier things to help you judge which amplifier, even if it's judged poor, may work perfectly fine with your speaker. Some of these anechoic chamber measurements that have wiggles here and there can be fixed at the listening position or at your listening position in your room. Those aren't going to be there. It could be totally different peaks and dips. So if you had that speaker measuring perfect in an anechoic, it may be worse for you at your listening position. There's no guarantees from certain measurements of what it's going to sound like. And so what I wanted to do is not castigate those guys for doing that. I think they're doing a great job doing that. It's definitely needed, but bridge the gap between what does it really mean? Because some people put so much weight into it and think it tells you how it sounds, and it really doesn't. And then on the flip side, the people just doing audiophile jargon, you have to really be comfortable with their ears. And it brings up the macro point I wanted to share here. We're talking about a lot of complex things that I'm sure many people are like, this is above my head. I just want to listen to my music. I don't want to understand even these graphs. Well, again, that's why it's important and why I've learned and always tout, have people like Steve in your circle of trust, people that can explain these things to you. Or if you don't, hey, is this amp with these specs going to work good with my speaker? Or I'm having a problem with.
And that's a point that I want to make very clearly. And that is, I think measurements are not that useful in isolation. If you're looking at a measurement of a piece of equipment and you're seeing specs on that, okay, it tells you something about that piece. But where measurements have some value, I believe, is in understanding how these things work together, how they match up synergistically or not. And there are a few specs that can be useful in that regard. I mentioned speaker sensitivity. That's a huge one because that relates very directly to amplifier power and how much sound you're going to get out of that speaker, the levels with a given amount of power. With amplifiers, I like to know the gain of the amplifier and the input impedance. Those are things that can help me with interfacing with other appropriate pieces of equipment. I like to know the idle current of a piece, along with its power rating. It gives you some idea of how much juice you're going to be, using continuously. And that varies all over the map, depending on you go from class D, which has almost nothing as idle current, up to some great big tube amps that are sucking a lot of juice just when they're on, period. And then with preamplifier gain is useful. Knowing the output or source impedance can be very important. How is that going to match with your amplifier? If you have a tube preamp that has a very high output impedance, as some do, and you happen to have say a solid state amplifier with a relatively low input impedance, that's not a great match, and it's good to know that. It's also preamplifier gain is relevant, but it's very much regulated by the volume control. So what kind of a volume control is there? People don't talk about that. You don't see that in the specs. You might see it mentioned in the body of, the description about that piece of equipment. But that, to me, that's like one of the most important parts about a preamplifier. What kind of a volume control is it? And does it have the resolution to deal with the gain? If it's a high gain preamplifier, You want a high resolution volume control, and a normal potentiometer is not that. Even a stepped attenuator may only have a relatively small number of steps. It's only when you get into volume control designs that have a lot of steps over a broad range that you get very high resolution of whatever gain there is in the preamp that gives you the control you need to get the volume settings you want correctly. And then you get to things like phono cartridge. Well, you need to know the output voltage because that relates to your phono preamp and what you need in a phono preamp for that. And then I like to know the compliance so that I know how that's going to behave with a given tone arm's effective mass to get the resonant frequency of that system into the ideal range of around 10 hertz, give or take a little bit. But that becomes very fundamentally important for the behavior of that whole system. There's lots and lots of other specs, but that's just in a nutshell the things that are kind of I look for as being kind of first order importance of how to get things to work together synergistically.
Yeah, and even if you get all your gear synergistically working together, friendly impedances, friendly gain, top-notch parts quality, then you're still only 50% of the way there, because then you got to measure how all that system together perfectly coordinated and synergized works in your room, because then the room is going to throw all that stuff.
Well, the room is the most important factor of all. And we're not, these measurements don't deal with the room. That's a whole separate deal, but that is the most important factor. Really is the room, the speakers you've got, and where the speakers are within the room. Now, you've got a situation with the Bach, and now that, coming with the optimal room correction capability that goes a long way toward fixing a lot of room interface issues with the speaker. But that's still relatively unusual. There are people that have other DSP correction systems using room equalization wizard and various things like that can be extremely helpful. But the great majority of people are still, taking their speakers home, plopping them down in the room, and hopefully playing around with them until they get, a good balance of performance at where they need them to be. But and the room is a huge factor that they don't have a lot of control over in terms of size and shape.
And that's why I'm also promoting and why I represent of all measurement tools, the Bach, because of the in-ear measurements at your listening in your room. And I just had 2 sets of people come out yesterday. We all measured differently. The ear didn't change, the seat didn't change, the room didn't change. Each person's ear alone measures differently. So when you're doing corrections that are not only for issues in your room, things that you can't correct with room treatments to the precise level that is necessary, but also psychoacoustic factors the Bach takes into account, your ear pinna, your torso, we all have different. Really the only variables left once you have that is your own innate hearing loss and whatever preferences, but then there are adjustments for you to do that on your own as well. But that's where I'm hoping to bridge the gap with this series and really take this one FTC pronouncement of, yes, this is moving the bar a little bit with one spec, but more importantly, the takeaway is all these specs need to be taken in some cases with a grain of salt, and in a lot of cases, only a few grains of salt. You need to have the expertise of people like Steve. If you don't have that expertise to explain to you when it might be applicable to you and a problematic match between components that won't work for you, or when it will and you can ignore certain stats, getting this kind of expertise, and that's what I've developed over 40 years, and have the circle of people around me that when I don't know, I can go ask and not just randomly trust some anonymous guy on a audiophile forum or YouTube or whatever that never talks about any of this stuff or knows any of this stuff, has never experienced the levels of stuff that an actual person like Steve and has 40 years experience like me, hearing just about everything. We're here to help, and that's why I wanted to do that series, to show people it's a lot more complicated than just looking at a spec and ranking things on these specs.
Yes, indeed. Comes down to system synergy, which I think most of your viewers are very familiar with. But ultimately, you've got to get that gear in your room, hooked up, working, and figure out if they're all playing nice and giving you the performance that you're looking for. And unfortunately, you can't know in advance just by looking at the specs. They can tell you some things, but ultimately they're not a complete answer. So experience is the key.
Yeah, I guess that's a good point to wrap up this first video, both covering the FTC and some good insights on your part. Now, if you want to join my membership group, the WhatsApp group, Steve is in it, other experts, as well as audiophiles that give you really good advice and help fill in those blanks where many people, and I count myself as one of them, early on knew nothing. I'm much more advanced now, but there's still times when I have to call in the experts, and I have those experts at my disposal in the WhatsApp group to give me this kind of insight. And I think this cube thing this was new to me. Steve pointed this out, and I wanted to share that with you guys, make sure you got an understanding of this as well. And maybe somebody will be inspired by it that does measurements, can buy this technique and start providing these in addition to the normal FTC specs for amplifiers, but we'll see how that goes. I'll be doing a lot more in the future, but want to thank Steve, and maybe we'll do this again in the future, future topics similar.
And don't forget, if you join Jason's WhatsApp group, you have access to his new hat line. And I understand he's designing a listening hat.
A special hat. The correct bad ear pinna,
Exactly. Yeah.
Hearing loss.
You take the measurements, you send them to Jason, he will make you.
And I will customize the hat to reflect the sound perfectly for you. Actually, I am releasing I'll have the website soon for my cowboy hat line, because again, too much. I could probably sell more of those in box, and I'm selling a lot of box. We're gonna have a race next year. I told Edgar, am I gonna sell more hats or more box? But anyway, that's soon to come. Thanks again, Steve, on this Sunday joining me, and
you're very welcome.
And
people, if you have questions, let us know. We'll do our best to be helpful and answer.
Yeah, post some comment. We're going to read the comments. So post a comment, any questions you might have, or join the WhatsApp group, and you can have one-to-one talks with us. All right. Well, have a good night, Steve. Good seeing you again.
All right. You too. Thanks very much.
All right. Take care.
Stay so long.